Hello everyone. So in today's video we are going to be doing three things. Firstly, we'll look at the different types of data. Secondly, we'll look at data representation, and lastly we'll talk about symmetry. My name is Sithole and I'm a statistics and macroeconomics tutor. If you are interested in joining our bootcamps, please don't hesitate to PM me on WhatsApp. Without wasting time, let's get right into today's content. So firstly, let's discuss the types of data that we have. So we have what we call raw data. So raw data is what we have right here. Raw data is unstructured data. You can't make sense of this data and you can't take decisions based on just this data without analyzing it into information, if I may say. So say for instance, as you can see from my screen, you have 1 1 1 1 1 2 2 2 2 2 3 3 4 4 4 5. You just have a bunch of numbers and you need to now process this raw data and represent it in a different way so that you're able to make decisions, or so that this data can tell you something that can help you make a better decision, right? So we just have raw data. You just collected this data, you haven't processed this data, right? So that's just what raw data is about. It's just any unprocessed information, right? And then we have what we call grouped discrete data and grouped continuous data. So when they say grouped, they are saying I'm going to take this raw data that I have collected and I am now going to have what I call a frequency. So whenever you are thinking of grouped data, the first thing you should look for is your frequency, and frequency speaks to how often does something occur, right? So frequency will speak to how often something occurs. Something occurs, right? And then in these two types of grouped data, you're going to have grouped discrete and grouped continuous. And when we are saying grouped discrete means you are counting, right? So you have one bottle, you have 3 cell phones, you have 2 rulers, you have 5 calculators. It's something that you can count and something that cannot be counted in half. You cannot have half of a calculator, but you can have 1 calculator, 2 calculators, etc. So that's what in essence grouped discrete data is all about. It's all about something that you can count, right? So in the example that I have, we are talking about cell phones. Cell phones are things that you can count. So when you're reading the information that they give you, that small paragraph detail that tells you what your question is about, you need to look at what the subject of that question is. Are they talking about cell phones, or are they talking about when you're measuring something? Are they talking about time, or are they talking about people? Because that will really inform you on the type of data that you would be working with. If they are talking about things like people, you can't have half a person, so that tells you that it's going to be grouped discrete data that you are dealing with. But if they talk about something like time, you know you are measuring, and it's going to be grouped continuous data, right? So I said for grouped you look for frequency, for grouped discrete you are counting, for grouped continuous you are measuring something, right? And you need to look for your class intervals if you are working with grouped continuous data. So that's how you would be able to analyze that paragraph given, right, in your question, and then identify the type of data you'd be working with, right? So those are the 3 types of data that we have. And then if we just had to look at how data can be represented, obviously it can be represented in intervals, etc. It can be represented in intervals, but what I want to focus on really today are the graphs that you could have. Obviously, you also have a bar graph. A bar graph is going to represent grouped discrete data. However, a histogram, on the other hand, like what I have on this picture, is going to represent grouped continuous data, because you are continuing from one interval to the other, right? It's grouped continuous, right? For grouped discrete, one bar is not moving to the next bar, right? If whatever subjects you had on the x-axis, if it was 1, then you have 2, then you have 3, it's not 1 to 2, it's just one subject matter, then you have 2x, 2 and 3, right? I'm not sure if I'm making sense. But for your histogram, now we're saying you're moving from 20 to 30 and moving from 30 to 40, then moving from 40 to 50, right? So that's what a histogram is. A bar graph, so when you see a bar graph on your question, it should trigger you that the data that I would be working with here, if it's a bar graph, would be grouped discrete data. But if I see a histogram in my question, then I should know instantly that I'm working with grouped continuous, because you cannot represent group discrete data in a histogram, but you can only represent it in a bar graph, right? So a histogram, on the y-axis is going to have your frequency, how often that x value occurs, and then on the x-axis you're just going to have the subjects of your formula. So if you are dealing with the age group, just like in our question, what's on your x-axis is supposed to be the age group, right? And then we also have what we call a frequency polygon. So a frequency polygon is going to take the midpoints of your x values and draft them with their frequency. So on the y-axis you will have the frequency. However, on the x-axis we are going to now point or plot the midpoints of your x-axis. And another way that a frequency polygon is drawn is that you just take the midpoints of your histogram, right? So you go to the midpoints of your histogram, midpoints is supposed to be something here, midpoints of histograms, midpoint of histogram, and then you draw it, right? So you would have something like this. Excuse how it looks, right? Just like how you have it here. You have it on the midpoints of your histogram, right? So just to sum it up, for your frequency polygon, you need to draft it using on your y-axis your frequency, and then on your x-axis the midpoint of your x subject. So if it's your age, it's going to be the midpoint of your age groups, right? So if you haven't subscribed, please make sure you click that subscribe button, as it tells me that this video is helping you and I should continue doing more. Next, I'll be talking about percentiles, so make sure you stay tuned to that video. And then the last one that we now need to look at in terms of data representation is what we call an ogive, right? Some say an ogive, some say an ogive. It doesn't matter, as long as you're able to do your calculations, you'll be just fine. So an ogive is supposed to be S-shaped, right? So with this one and this one, we're saying frequency and whatever your x is. But with an ogive now, we're saying take your cumulative frequency, right? And this is something very basic. If you don't know how to calculate your cumulative frequency, make sure you go back to your notes and you study that, right? So you take your cumulative frequency, instead of plotting your frequency on your y-axis, for an ogive you plot your cumulative frequency, and then on your x-axis obviously you have your subjects of the formula, right? So those are the different ways that you can represent data. And this is important, as dumb as it may seem. This information is the one that is going to help you answer questions, right? Because they will give you a graph. They might not say it to you in words, they might say it to you graphically, and you need to have the knowledge at the back of your head to say, okay, I'm dealing with a histogram, so I know that whatever value I have on my y-axis is a frequency, and whatever value I have on my x-axis is the subject matter of my question, right? If I have a frequency polygon, I know that those x values that are plotted in that frequency polygon are actually my midpoints and not the x values themselves, right? And then if I have an ogive, on the other hand, I know that whatever values are being plotted from my y-axis is a cumulative frequency, right? They might not tell it explicitly to you, they might not even label it for you. You need to know that if it's a histogram, this is how it was plotted. What was the subject on the y-axis? What was the subject on the x-axis? And lastly, we are going to talk about symmetry, right? So there are different types of symmetry that you could have, or skewness, right? It could be symmetrical. So we are looking at how your data is distributed, right? Is it symmetrical, or is it positively skewed, right? So positively skewed, or is it negatively skewed, right? So those are the different ones that we can have. Let's discuss them. How would you see that the data is positively skewed from just being given numbers? So when data is symmetrical, you will see that your mean is equal to your mode equal to your median. So when data is symmetrical, the mean value should be equal or approximately equal to the median equal to the mean, right? So mean equal mode equal median, right? And then when your data is positively skewed, right, you always start with the highest point. The highest point is your mode, right? Because it's the value with the highest values. So you start with your mode, and then you go on with your median. Where do you guys think the median is gonna be, right? The median is obviously gonna be in the middle. So in this instance, it's gonna be to the right of your mode, right? I hope you guys are still following what I am going on about, right? So the median is going to be on the right of my mode, because it can't be this side. How can it be a median? A median is a middle number, right? So how can it be to the left of the mode when you can see that most of this data is spread to this side, right? So you're gonna have your median, and lastly you're gonna have your mean, right? So think of it this way: in a test or an exam, just draw a simple sketch for you, right? Let's say they didn't give you a sketch, but they gave you numbers, and you need to tell them if it's symmetrical, positively skewed, or negatively skewed. You draw this table, you start with your mode, and then you ask yourself, where would the mean be? Would it be to the left of the mode, or would it be to the right of the mode? As you can see in this instance, it's to the right of the mode. I'm not sure if the way you guys are seeing my screen is the way I'm seeing it, but it's to this side, right? To the right of your mode. The median is always the middle, so have that sketch, right? Have it positively skewed, right? And then look at where the middle would be, right? And then lastly have your mean. So you guys can see from this table that when data is positively skewed, right? So remember that this is kind of like an x-axis. As you go this side, the numbers are increasing. So when data is positively skewed, the mode will be less than the median, as well as less than the mean. And when data is positively skewed, then the median is gonna be less than the mean, right? So the median is gonna be less than the mean. Do you guys see that? And then when it's negatively skewed, on the other hand, as I said, always start with the highest point, that is your mode. Then you ask yourself, where would the median be? Where would the middle number be? Would it be to this side or to this side? As you guys can clearly see, it will be somewhere here, right? So you have your median, and then you have your mean. And as you can see here, when the data is negatively skewed, meaning most of the data is to the left, right, you guys can see that the mode is greater than the median and the mean is less than the median. So just have a sketch for yourself and write it as I just taught you, so that whatever numbers you are given, you're able to tell the marker that it's positively skewed or it's negatively skewed. We've come to the end of our session. I hope this helped you a lot. Please make sure you subscribe to my YouTube channel, and please do come to my bootcamps. We'll do quite a lot of past papers to prepare for your guys' test one, so make sure you're on the lookout for that poster. Bye guys.